All right, so far we have covered CRUD operations, validation, subdocuments, and virtual fields. Whoa, what could be next? Well, we could say that we have explored most of the very basic and core elements of Mongoose. So from now on, we're going to talk about how to design MongoDB databases. So let's just have a look at our student.js file. And we can see that there is only a collection of students here, and it's really nothing much. So we're going to learn a little bit more about how to design this student schema. Now, although this, of course, works properly, we do have a few shortcomings. And yeah, we're going to talk about it. So just imagine an application mockup, and we may see it like this. There's a list of articles with their titles and students that we store in our student model. And every article has a title on the left and the students are on the right. However, maybe our schema doesn't really make this display. Just think about it for a minute. We want to have multiple articles, and these articles are from different students, and we want to be able to show them in an application. So we might write some code to look like this. First, we want to have all the students in our collection and take their list of articles and make one list containing each article from each of our students. And sure, but this approach is kind of problematic, actually, because, well, first, we wouldn't want to show just an endless list, a list with an infinite number of articles, right? It just goes on and on. And how do we know that it just goes on and on? Because we don't know the size of the application and the number of students inside this. So there might be thousands of articles that are going to be shown. We would want to show a particular amount of articles, though, on one list. In other words, we will want to limit the number of students. However, if we use this kind of query, it really is kind of hard and complex to limit it to, for example, 10 articles. But on the other hand, the students that we fetch from the database might have no articles at all, and the list will be shown as a list with no articles. So remember that if we're going to be wanting to see every article of one student, our schema will have to be perfect for that kind of stuff. So let's analyze another mock-up here. Imagine that we have a list of articles like the previous one, and if the student clicks on a particular article, say the first one, we may see this kind of page. And what you're looking at here is the title of the article on the top, then the student name, the content, and then lastly, the comments. You see what we're doing? We enable other students to make comments inside the article of other students with nested data structure. So actually the challenge is, how can we handle the recording of who made a specific comment? Now remember, we did talk about how to know who makes the article in previous videos. We know here who made this article, but in the context of comments, this is kind of problematic because comments are made by different students. How can we take this data from our schema? So we can use student.name for the student, student.article0.title for the title, student.article0.content for the content of the article. But how are we going to nest the comments of different students? So it is challenging, because it's pushing the bounds of nesting data structures. So let's think about it. Think that we nest comments inside the particular article, and then this article will be put inside the students. So it's really hard to write a query to take all the comments of a particular student. So in order to avoid that, rabbit hole. Maybe, just maybe, we can use more than one collection rather than having one in which each student has a nested collection of articles. So yeah, I think we can solve this problem by creating 3 different collections inside the application. Let's see, there may be a student collection, an article collection, as well as a comment collection. So I think it's going to be much better than a nesting subdocument. So if we want to find the articles of a particular student, we just ask the article collection to give the IDs, which are inside of the article IDs property of a particular student. You follow? And there is a comment collection, so we can record the comments of a particular article on a property comment ID and record that on an article. Now, if we want to see the comments of the article, we should look at the comment IDs property here and take the list of all the comments. And then for the last step, we could see which comment belongs to which student, and all the comments record student ID properties, which points back to the student collection. So actually, this approach could solve most of our problems because it makes things pretty straightforward in its path. For example, we can take only a limited number of articles in a particular student and see all of the comments inside of it. However, we should say that there is a downside to this way. Well, the downside is about the performance issues, because as you might imagine, we've got 3 different collections, one for student, one for article, one for comments. So that means we have to touch our database every single time. Now, if you're familiar, inside of SQL databases, we could do all these with a single query. But in MongoDB, it's a little more challenging. So let me put all this in a nutshell. Both approaches have pros and cons, and in the nested document approach, it's really hard to achieve this kind of stuff while we're struggling with performance issues when we have to use separate collections. So, next time, we're going to continue to solve this problem.